Hello again, grade sevens. In today's lesson, we are going to continue to look at two different independent events. Uh, we're going to continue to represent these independent events, both in tables and tree diagrams, but we're going to add something a little bit different today. In addition to visually representing these different outcomes, we're also going to do some probability calculations for a combination of two independent events. Before we do that, though, it's going to start off with a definition of what a random event is. A random event is one in which every outcome has an equal chance of occurring. The example of this would be either flipping a coin or rolling a die. Flipping a coin, you should have an equal chance of flipping heads or flipping tails. Although I think sometimes you might, over a lot of trials, you might start to get a little bit more shifted towards heads or tails, depending on how the coin is weighted. But theoretically, it should be just either an equal chance of flipping heads or tails. Same thing with rolling a die. You have a six-sided die. If you roll it, there should be an equal chance of obtaining every one of the possible outcomes, either the 1, the 2, the 3, the 4, the 5, or the 6. This diagram shows a situation where you would not have a random event. So I have a spinner that's divided into 3 equal sections. But the problem right here is that when you look at the spinner, 2 of the sections are a P. So if I were to spin this thing, it's much more probable that you're going to land on a P in comparison to an R because you have twice the area in terms of where you could land on a P in comparison to an R. So utilizing this spinner would not be a random event since it is much more likely that you would spin a P in comparison to an R. For the most part, we're going to look at situations just where we're going to have events that are random. We could still do a probability calculation for this because we'd have two different sections, but we generally want to stick towards situations where the events are random. Let's jump into an example problem. A loonie is flipped and a 6-sided die is rolled. I want to express all the possible outcomes using a tree diagram and then identify how many possible outcomes I have. All right, so this is actually going to be a really big tree diagram. So I'm going to start off by, for a tree diagram, at the very top, you should identify which object you're dealing with. And I like to always start off with the object that has the fewer number of outcomes. So I'm going to pick the loonie. Okay, so the loonie, you have 2 possible outcomes. Either you can have heads or you can have tails. Then we're going to write down a heading for the second object, which is the die. And then we're going to branch these trunks, the heads and the tails, into different possible outcomes for the die. So one branch would be heads goes to the number 1, heads goes to the number 2, heads to the number 3, heads to the number 4, heads to the number 5, and then heads to the number 6. As for tails, you have tails followed by 1, tails 2, tails 3, tails 4, and then tails 5, and then tails and 6. So a little bit larger in comparison to the diagram we drew, the tree diagram we drew in the previous lesson. All right, B, identify the total number of possible outcomes. So the way you do that again is just count the different total number of branches on the tree. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. There are 12 possible outcomes. So far in this example, this is nothing new in comparison to what we've done in the previous lesson. But now we want to do some probability calculations based on these independent events. So let's see what we've got here. I want to calculate the probability of flipping heads and then rolling the number 3. Okay, so let's set the calculation up. So I'm going to say probability. And what I want to do is I want to get heads followed by 3. So in brackets, I'm going to write down H3. H3 means event the first independent event, which is heads, followed by the number 3. Okay, that's equal to the favorable outcomes divided by the possible outcomes. I know what the bottom here is. The number of possible outcomes is the total number of branches on the tree. That was 12 of them. I'm now going to go back to the tree and see how many possible ways I can actually get heads followed by the number 3. So if I go back here, and let's examine this. I'll do it in a different color. How many ways can you get heads followed by the number 3? There's only one way you can get it, okay? Heads followed by the number 3 would just be this. So if I go back to this now, there's one favorable outcome. There's only one way you can get heads followed by the number 3, and that is 1 divided by 12. Okay, now we like to express probability as a fraction, a decimal, and a percentage. So I'm going to convert this into a decimal number by taking the numerator and dividing by the denominator. So 1 divided by 12. This is going to give me a repeating decimal number, though. So I'm going to have 1 divided by 12 would be equal to, I'll write this down, 0.0833333, and it's a repeating decimal number. It'll fill the rest of your screen on the calculator. But what I want to do here is I want to round this. And I want to round this to the nearest thousandth of a decimal, which is the third decimal place in. However, to round it correctly, you need to look at what the following digit is. So the following digit after the 3 is a 3. If the following digit is a 0 through a 4, you don't round this number up. If the following digit is a 5 through a 9, you just round it up by 1. Since the following digit's a 3, we don't do anything right here. So I would actually just write this as 0.083. To convert this into a percentage, what you need to do is multiply by 100. Now, when you multiply this by 100, you have to move the decimal spot 2 units to the right. So this would actually be, you move it 1 over to the right, and a second one over to the right, and you'd actually have the decimal then between the 8 and the 3. Therefore, the percentage would then be 8.3%. So just be careful. If you see the 8.3, doesn't necessarily mean it's 83%. It's about how you move the decimal spot. If you multiply by 100, you move it 1, 2 spots to the right. That puts the decimal right between the 8 and the 3. Okay, the second one wants me to calculate the probability of flipping tails and then getting an even number. So let's set the equation up again. So I'll say probability of getting tails. And we'll put a comma here, and we'll just say even number. That's going to be equal to your favorable outcomes divided by your possible outcomes. Okay, the tree has 12 branches, 12 possible outcomes. And now what we need to do is we need to go back to the table and we need to identify how many possible ways can you get tails followed by an even number. I don't know why I wrote down number 2 there. Let's erase that. I don't know what I was thinking. There we go. 2 is an even number, but we have more even numbers than that. Okay, so let's go back and figure this out. Okay, so I'm going to do this in blue. Okay, so we want tails and an even number. The only even numbers you have here are 2, 4, and 6. So one combination is you could get tails and 2. That's the first even number. You could get tails and you could get the number 4. That's a second even number. And you could also get tails and the number 6. So those are all of my possible ways I could get tails followed by an even number. So there's 3 favorable outcomes here that I could obtain. Tails and 2, tails and 4, tails and 6. 3 favorable outcomes. So if I go to the probability calculation and fill this in now, this would then be, let's go back to red, 3 over 12. And 3 over 12 is going to be a nice terminating decimal. So that's going to be 0.25. So you don't need to worry about the rounding if it's terminating. 0.25. And then to convert 0.25 into a decimal, move the decimal 1, 2 spots to the right. And that would give me 25%. So 25% chance of flipping tails and rolling an even number. A third one, what's the probability of flipping heads and then rolling a number that is less than 6? Okay, the numbers that are less than 6, now we can represent this in a couple of ways. The less than operator looks like this. We have less than 6. And less than 6 means any number obviously less than 6. So that can be 1, 2, 3, 4, or 5, okay, based on our 6-sided die. Okay, let's set the equation up. And again, we need to show this work. Okay, we have to communicate like what we're doing. So we'll write down probability of getting heads. And then I'm going to put down heads and then a number that is less than 6. And that's going to be equal to number of favorable outcomes divided by the number of possible outcomes. The number of possible outcomes, again, is 12 because you have 12 branches on that tree. And now we have to figure out how many favorable ways you can get heads followed by a number that's less than 6. So let's go back to the previous slide on the tree diagram and determine that. And let's do that with purple this time. Okay, heads and a number that's less than 6 would be heads and 5 is less than 6. Heads and 4 is less than 6. Heads and 3 is less than 6. Heads and 2 is less than 6. Heads and 1 is less than 6. By the way, you don't need to circle these in your work. I'm just simply illustrating the favorable outcomes. So there are 1, 2, 3, 4, 5 ways I can get heads and then get a number that is less than 6. So let's go back to my calculation now and determine this. And let's go back to red. So it's going to be 5 over 12. Now, 5 over 12, if we calculate it, again, to calculate it, just a fraction is a division. So you got 5 divided by 12, and I suspect this is going to give us an ugly decimal number, and it does. It gives you 0.4166666 repeating. Once again, because it's a repeating decimal, we want to round it correctly, and we're going to round it to the nearest thousandth, so the third decimal place in. To round it to the nearest thousandth, I need to look at what digit follows. Now, the digit that follows is a 6. That's a number between a 5 and a 9. So what that tells me is I need to actually round this number up by one digit, by one number. So when I write this down, it would then be 0.417. And then to turn this into a percentage, move the decimal spot 1, 2 units to the right, and that would give me 41.7%. So 41.7% chance of you flipping heads and then getting a number that is less than 6. All right. What's the probability of rolling a number that is larger or greater than 2? Okay, so we want a number that is bigger. Whoops, let's get rid of that there. Okay, so number that is greater than 2. So the greater than operator looks like this. On our 6-sided dies, the numbers that would be greater than 2 would be 3, 4, 5, and 6. So let's set up the calculation. Again, we want to show this work. So we have the probability of getting tails and then getting a number that is greater than 2 is equal to your favorable outcomes over your possible outcomes. And that would be equal to, you still have 12 possible outcomes, 12 branches in the tree. And now we have to go back and determine the number of favorable outcomes, favorable ways we have tails, and a number that's greater than 2. So let's go back to this. And let's do this in, let's see which color here this time around. Maybe orange. Okay, so numbers that are greater than 2 would be 3, 4, 5, and 6. So the number of ways I can get tails, followed by a number that's greater than 2 would be tails and 3, tails and 4, tails and 5, tails and 6. And again, you don't need to circle this on the tree diagram. In fact, don't do that because it would make the tree diagram super messy. I'm just doing it to illustrate once again what the favorable outcomes are. So to get tails in greater than 2, there are 1, 2, 3, 4 possible ways you can attain that. Or 4 favorable ways that can be obtained. Okay, so this would then be 4 over 12. Now, 4 over 12, if I calculate it, is again going to give me a repeating decimal number, which is 0.33333, and it repeats on like that. Okay, so I want to round to the nearest thousandth. To round to the nearest thousandth, we look at the following digit. The following digit is a 3. That is a number that's between 0 and 4. Therefore, we don't round that digit up. We keep it as a 3. So this would then be 0.333. And if you convert that into a percentage, move the decimal spot 1, 2 units to the right, and then you'd have 33.3%. All right, so we took the information from the previous lesson, which was just representing these independent events on a tree diagram or a table. And we also combined that with our probability calculations that we dealt with in the first lesson. So a little bit tougher compared to either of those lessons individually. The assignment to complete is on page 175, numbers 3 through 9. And I just made a quick note here. If you prefer to draw a tree diagram instead of a table, you may do so every single time you're asked to draw a table or vice versa. I find it a bit more useful to do the tree diagrams. Oftentimes we might be asked to make a separate column, like a column where we add different numbers together. And that's a lot easier to do with a tree diagram compared to a table. So the tree diagram is definitely the preferred way to represent the different possible outcomes for two different independent events. But again, just make sure you're capable of doing both of them. All right, so that's the end of this lesson, and I'll talk to you in the next one.